In the early years of the 20th century, astronomy was still bound to the Earth. Telescopes peered into the night, but the universe was imagined as static, eternal, unchanging. The Milky Way was thought to be the whole of existence. Beyond its starry expanse, many believed, lay only darkness and silence. But hidden in that silence were signals waiting to be read. In 1929, Edwin Hubble, working at Mount Wilson Observatory, revealed something extraordinary. Galaxies, once thought to drift aimlessly in a quiet firmament, were receding from one another. The farther away they were, the faster they fled. The universe was not fixed. It was expanding. This discovery tore a seam in the fabric of human thought. If everything was expanding outward, then at some inconceivably distant moment in the past, all matter and energy must have been compressed together. Hubble's galaxies were like sparks from an ancient fire, drifting outward into the cold. Somewhere there had been an ignition. Somewhere there had been a beginning. Even before Hubble's measurements, a Belgian priest and physicist named Georges Lemaître had suggested something radical, that the universe had emerged from a primeval atom, a single point containing all that would ever exist. His idea, first dismissed as too fantastical, now seemed hauntingly prescient. It carried within it the seed of the theory that would come to dominate modern cosmology, the Big Bang. Still, the Big Bang was more than a theory of origins. It was a confrontation with existence itself. For if the universe had a beginning, then time itself had a boundary. The clock of reality had not always been ticking. There was a moment before which no seconds, no minutes, no ages had passed. For the first time in scientific history, physicists were forced to ask, what does it mean for time itself to have a birth? The decisive evidence came not from starlight, but from a faint echo hidden in the sky. In 1965, Arno Penzias and Robert Wilson, working with a radio antenna in New Jersey, stumbled upon a signal they could not explain. No matter where they turned the instrument, a persistent background hiss remained. They thought it might be interference, or even the droppings of pigeons nesting inside the device. But when the noise would not vanish, they realized what they had uncovered. The afterglow of creation. This signal, now known as the cosmic grow wave background, was the fossil light of the Big Bang itself. Photons, released when the newborn universe, cooled enough for matter to form atoms, had been streaming across space for nearly 14 billion years. The universe carried its own birth certificate in light, written across the sky. The Big Bang was no longer speculation. It was evidence, it was data. It was the story written in every direction a telescope could see. And yet, even as the evidence hardened, unease remained. The Big Bang explained how the universe expanded, but not what lay before. It spoke of a beginning, but it did not reveal what that beginning truly was. Did all of existence erupt from a singularity, a point of infinite density, where the known laws of physics collapse? Or was the so-called beginning simply a transition, a moment in a cycle that had been unfolding endlessly across cosmic time? Einstein himself had long been uneasy with beginnings. His equations of general relativity allowed for a dynamic universe, but he first resisted the idea. He introduced a cosmological constant to keep the universe still, eternal, balanced. To Einstein, the thought of a singular origin seemed unsettling, even unnatural. Later, when Hubble's evidence forced the removal of that constant, Einstein admitted his error. Yet the discomfort remained, lingering in the margins of cosmology. Beyond physics, echoes of older wisdom returned. Ancient cultures had spoken of cosmic cycles, of universes born and reborn in eternal rhythm. The Hindu idea of kalpas, or great cosmic breaths, in which creation expands and contracts over unimaginable timescales. The Greeks imagined ekpyrosis, a universe destroyed and recreated in fire. These were myths, not science, but they carried a haunting resemblance to the questions now emerging from modern cosmology. If the universe was expanding, it must have begun. But if it began, might it begin again? Here, the scientific tension emerged in full. Expansion did not just imply an origin. It suggested the possibility of recurrence, of cycles, of breaths. The cosmos could be not a single firework exploding into darkness, but a vast heartbeat pulsing through eternity. This was the paradox into which cosmology had stumbled. Science had uncovered the beginning, but in doing so, it opened the oldest question of all. Was this the first? Or only the latest inhale in an endless rhythm of creation? The Big Bang became both an answer and a doorway. It revealed the story of how time began, but left unanswered the question of what lies beyond that boundary. Before the first moment, before the first breath. Scientific shock asterisk, the Big Bang had triumphed. The galaxies receded. The cosmic microwave background whispered its confirmation, and the early universe revealed itself through physics and light, yet hidden within the very equations that gave birth. To this triumph was a paradox so deep, so unsettling, that it shook the foundations of cosmology. General relativity. Einstein's great theory of space and time worked with astonishing precision across the cosmos. It described the bending of starlight by gravity, the dance of planets, even the collapse of stars into black holes. But when applied to the universe's beginning, it produced something far stranger. A singularity dot. At the singularity, density and temperature rose without limit. The curvature of spacetime became infinite. The mathematics that governed stars and galaxies, particles and fields, simply broke apart. Here was a boundary where physics dissolved, a place where the laws of reality could not follow. This was the shock. The Big Bang was not a neat beginning, not a stable equation unfolding with elegance, but a rupture. It was a place where science lost its grip. The most powerful theory humanity had ever created pointed not to an answer, but to its own collapse, and yet even this collapse carried implications that were more than scientific. If the singularity was real, then time itself had a sharp edge. There was no before, no earlier chapter, no deeper root. The universe had erupted from nothing. Existence itself had begun in an instant of creation. For many scientists, this was not a triumph, but a terror. Physics rests on causality, on the chain of events stretching backward, each effect with its cause. But if the Big Bang was the ultimate cause, with nothing before it, then science faced the unthinkable, a cosmos without precedent, a reality born from absence. Stephen Hawking once described this moment as the boundary of time. To him, asking what came before the Big Bang was like asking what lies north of the North Pole. The question itself dissolved at the edge. For Hawking and many others, this was a shock not of science alone, but of philosophy. The universe was finite in age, yet infinite in implication. Quantum theory only deepened the unease. In the quantum vacuum, particles can flicker into and out of existence, emerging from fluctuations in energy fields. Could the universe itself have emerged in such a way, a vast quantum fluctuation on the grandest scale? If so, the Big Bang was not the beginning of nothing, but the trembling of an eternal field. But if that field existed before the universe, then what truly had begun? Here, the strangeness multiplied. Relativity demanded that time began with the Big Bang. Quantum physics whispered of fluctuations that might not require time at all. The two great pillars of science, each so precise, stood at odds. Their clash at the singularity was not just technical, but existential. What unsettled physicists most was how perfectly balanced the newborn universe seemed to be. At its earliest measurable moment, it held an incredibly low entropy, a state of exquisite order. Why? Entropy should increase. Disorder should grow. If the cosmos had emerged from a singularity, why had it not been born into chaos? Why had it begun in such fragile symmetry? A symmetry so delicate that the fate of galaxies, stars, and life itself depended on it? This low entropy was not only improbable. It was, to many, incomprehensible. Roger Penrose calculated the odds of such an initial state as 1 in 10 raised to the power of 10 to the power of 123. A number so vast it exceeds imagination. Such precision seemed almost unnatural, as though the universe had been tuned, or as though its birth was not a beginning at all, but a continuation of a deeper order. The scientific shock was thus twofold. The equations pointed to an origin, yet that origin was paradoxical. It demanded an explanation, but denied one. The Big Bang forced cosmology into a place that looked less like science and more like a riddle, and in that riddle, deeper unease began to grow. Was the singularity real, or only the failure of relativity to see beyond a boundary? Did time begin in a single flash of creation? Or had something existed before, something concealed from view? Some physicists recoiled at the word nothing. Could the universe truly arise from an absence? Or was nothing itself a misinterpretation, a void that was not empty at all, but filled with invisible fields, latent energy, unmeasured dimensions? In confronting these questions, cosmology entered a territory both exhilarating and terrifying. The Big Bang was no longer a mere scientific model. It was a fracture in knowledge itself, a mirror reflecting not only the birth of space and time, but the limitations of the human mind. The singularity loomed like a wall, impenetrable, absolute. And yet, walls in science have never stood unchallenged. Each limit has eventually been pierced. Newton gave way to Einstein. Classical certainty gave way to quantum uncertainty. Could the singularity, too, be pierced? Could what lay before the beginning be glimpsed? The shock of the Big Bang was not its expansion, not its fire, not its afterglow. It was the silence it left behind, the blank space where answers should be. The greatest discovery of cosmology was not only that the universe had begun, but that in beginning it had concealed its own origin, and so the mystery deepened. The universe had declared itself finite, but in doing so, it hinted at infinity. It had revealed its youth, but concealed its ancestry. It had spoken, but in its voice was a silence more profound than sound. This was the paradox that left physicists staring into equations with wonder and unease. The universe had a beginning, but what does it mean for something to begin if time itself is part of the story? Deeper investigation, if the singularity was the wall, then science's instinct was to look for cracks. The Big Bang explained expansion, but its mystery remained unresolved. To move forward, cosmologists turned their gaze not only outward, but backward to the first fractions of a second, to the invisible moments when the universe itself was still unformed dot in the 1980s. A bold new idea emerged. Alan Guth, a young physicist wrestling with problems in particle physics, proposed that the infant universe had not expanded steadily, but violently. In a fraction of a second, it had ballooned outward at speeds beyond comprehension. This concept, cosmic inflation, reshaped cosmology. Inflation explained much that had puzzled scientists. Why the universe appeared so smooth across vast distances. Why the cosmic microwave background looked nearly uniform in every direction. Why distant regions of the cosmos, which could never have communicated with each other, nonetheless seemed to share the same temperature, the same cosmic fingerprint. Inflation offered a solution. Before expansion, these regions had once been close, connected, touched by the same breath of physics. But inflation also carried unsettling implications. If the universe could expand so rapidly once, could it do so again? Could inflation be eternal, spawning not one universe, but many, a multiverse? A foaming sea of expanding realities, each forever beyond our reach. The theory solved problems, but it also multiplied mysteries. Meanwhile, physicists began to look for evidence of what inflation left behind. The cosmic microwave background became a canvas of clues. Tiny temperature fluctuations mapped in detail by satellites like COBE, WEO, and later the Planck Observatory revealed a universe with patterns of faint anisotropy, subtle irregularities, that inflation predicted. These ripples were the seeds of galaxies. The fingerprints of quantum fluctuations stretched across the sky. Yet, in these maps, some saw hints of something more. The cold spot, a vast region of unusually low temperature, became a focus of speculation. Could it be the scar of a collision with another universe? Or merely the statistical noise of chance? No answer was certain. But the mere possibility drew cosmology into stranger territory. The thought that our universe might not be alone, that other approaches sought to soften the singularity itself. In the mathematics of loop quantum cosmology, an offshoot of loop quantum gravity, spacetime is not continuous but woven from discrete loops, quantum geometry. At densities near the supposed singularity, this geometry resists collapse, preventing infinite density. Instead of a beginning, the universe bounces. A previous cosmos, contracting under gravity, might have rebounded into ours. The Big Bang, in this vision, was not a creation, but a transition. Such models were not fantasy, but rigorous attempts to merge quantum mechanics with relativity. They sought to peer beyond the wall, to replace the rupture of singularity with continuity. Yet their predictions were subtle, hidden in patterns of gravitational waves or delicate features of the microwave background, and still unease lingered. The data, though rich, did not speak with clarity. Inflation explained much, but its foundations remained speculative. The bounce erased the singularity, but at the cost of introducing a universe before ours, a hypothesis difficult to prove. Each deeper investigation answered one question only by opening 10 more. The paradox of entropy continued to haunt these inquiries. Why did the early universe begin in such improbable order? Inflation could stretch quantum fluctuations into cosmic structure, but it could not explain why the universe's initial state was so finely tuned for life. For stars, for time itself, some argued that entropy reset at each bounce, that the arrow of time itself might emerge from such cycles. Others wondered whether we lived in only one bubble among infinite others, and that our improbable beginning was not improbable at all, but inevitable somewhere in the endless C dot as data accumulated. The tension between knowledge and mystery only deepened. Each telescope, each satellite, each map of ancient light revealed more about the universe's infancy, but none could yet pierce the veil of what lay before. Perhaps the most unsettling realization was this: the closer science approached the beginning, the more the laws of physics themselves began to unravel. Gravity and quantum theory, the two great pillars, refused to meet. Their equations clashed in the earliest instant, as though the universe guarded its origin with secrecy. And so, deeper investigation did not resolve the mystery. It sharpened it. The singularity softened into theories of bounces, brains, or multiverses. The afterglow of creation revealed patterns that hinted at greater structures. But each answer, each equation, carried humanity further from certainty and closer to the abyss of unknowing. The universe had revealed its expansion, its fire, its echoes of light. But the question remained, was this the first breath, or merely the most recent in a rhythm older than time itself? Escalation. Mystery deepens each discovery, sharpened the outline of the cosmic beginning. Inflation explained uniformity. The cosmic microwave background confirmed expansion, and quantum models suggested alternatives to singularity. Yet beneath these advances, a deeper unease began to stir. Instead of closing the mystery, each answer opened a darker abyss. The Big Bang no longer looked like a clean beginning, but like a doorway, and what lay beyond that doorway was more unsettling than anyone had imagined. One of the great puzzles was entropy. The second law of thermodynamics dictates that disorder must increase, that time flows forward because the universe moves from order to chaos. But the early universe defied this logic. It was exquisitely ordered, a fragile state of low entropy so improbable that its very existence seemed unnatural. Roger Penrose calculated its unlikelihood as essentially zero, a number beyond comprehension. If the cosmos had emerged spontaneously, why had it not begun in disorder? Why had it chosen symmetry so perfect that the rise of galaxies, stars, and eventually life could unfold? This question grew sharper as cosmologists considered the arrow of time. Why does time move forward at all? If the Big Bang was a boundary, why was it set at low entropy? Could it be that each cosmic cycle resets the arrow, that time itself is reborn again and again? If so, the Big Bang was not an origin, but only a hinge in an infinite sequence. Other investigations deepened this strangeness further. The discovery that the universe's expansion is not slowing, but accelerating, shocked cosmology in the 1990s. Galaxies were not just fleeing one another, they were speeding up. Something unseen, dark energy was driving the cosmos apart at an ever-increasing pace. This raised a haunting question. If the universe accelerates without end, does that mean it will never collapse into another bounce? Will it expand forever into cold emptiness, the stars extinguished, the galaxies drifted into darkness? Or is dark energy itself a clue to a deeper structure, a field that breathes, capable of reversing its flow? The tension grew more severe with the possibility of cosmic scars. Some cosmologists propose that if our universe had collided with another, in the distant past it might have left an imprint on the cosmic microwave background. Faint distortions, cold spots, or strange alignments. Teams studied the Planck satellite's maps, searching for such evidence. None was conclusive, but the very act of looking betrayed the unease, the suspicion that our universe was not the only one. And if inflation is eternal, as many models suggest, then our cosmos is but a single bubble in an infinite foam. If so, then before the Big Bang is not a singular question at all, but an infinite one. Other universes may have bloomed and died, each with their own physics, their own beginnings and endings. In such a sea, the Big Bang was merely local, a small event in a far larger and unseeable reality, but this escalation did not end with the multiverse. Some theories suggested even more disturbing possibilities. In certain models of quantum fields, our universe exists in a false vacuum, a metastable state that could collapse at any moment. Such a collapse would spread at the speed of light, rewriting physics as it passed. If true, the universe is not eternal, but fragile, poised on a knife's edge of stability, awaiting a decay that could erase everything without warning. At each turn, the mystery grew sharper. What seemed like answers became paradoxes. The singularity became a bounce. The expansion became acceleration. The order of the early universe became a riddle of impossible probability. The cosmic microwave background became not a confirmation, but a canvas for scars of unseen realities. The deeper the investigation went, the more the universe refused to be contained within a single narrative of beginning, perhaps. The most terrifying possibility was philosophical. If time itself began at the Big Bang, then to ask what came before may be meaningless. But if time is cyclical, if entropy resets, if universes breathe in endless rhythms, then beginnings and endings are illusions. In such a vision, everything humanity knows, stars, galaxies, civilizations, is only a moment in an eternal inhale. And if this is true, then what we call the beginning may simply be one beat in an infinite heart. The shock of the singularity had become something deeper, a realization that the Big Bang was not an answer, but an escalation. Each observation pointed not to clarity, but to further dissonance. Cosmology no longer described a universe that was merely vast. It described one that might be infinite, cyclical, unstable, or unknowable. The mystery had not been solved. It had only deepened, spiraling outward, accelerating like the universe itself. And with each revelation, humanity stood further from certainty, staring into a cosmos that seemed to breathe in rhythms too vast for comprehension. Theories and speculations. As the mystery deepened, science turned to speculation. If the Big Bang was not a clean beginning, then what was it? If the singularity was not the edge of reality, but only the edge of knowledge, what lay beyond? The search for answers birthed theories as vast and strange as the cosmos itself. Some were grounded in mathematics, others in the strange marriage of physics and philosophy. All sought to answer the same question: what breathed before time began? One of the boldest ideas came from Roger Penrose. His proposal, Conformal cyclic cosmology suggested that the universe does not end in heat death nor in collapse, but in transformation. In his vision, the infinite future of one cosmos, stretched into near emptiness by dark energy, becomes, by a change of perspective, the Big Bang of another. Black holes evaporate, galaxies fade, but the geometry of space-time itself resets. Each eon follows the last in an eternal sequence. The universe, Penrose proposed, may be an infinite chain of lives, each beginning where the last one ends. Others pursued the bounce. In loop quantum cosmology, spacetime is not smooth but granular, woven of discrete loops at the smallest scale. As the universe contracts, this quantum geometry resists infinite density. Instead of collapsing into nothingness, it rebounds. Our Big Bang may have been the echo of a previous universe collapsing into a crunch. Time, in this view, does not begin. It cycles. A cosmic inhale, followed by an exhale, followed by another inhale. String theory offered yet another vision. In its higher dimensional mathematics, our universe is a three-dimensional brain floating in a larger space. Collisions between brains could ignite big bangs, each impact birthing a new universe of space and time. In this view, the cosmos is not singular but layered, a hidden architecture where universes are born like sparks from invisible collisions. Then came inflation itself, not just as a solution, but as an engine of endless creation. If inflation can happen once, it can happen forever. This leads to the picture of eternal inflation, a multiverse of universes bubbling endlessly from an inflating background. Each bubble holds different laws, different constants, different histories. Our Big Bang was not the first nor the last. It was only local, one expansion in an ocean of infinities. Such speculation edges into the philosophical. If infinite universes exist, does probability itself lose meaning? Is our own cosmos tuned for life by chance or by necessity, inevitable in a sea where every possibility unfolds? If entropy resets with every bounce, then does history repeat, or is each cycle unique? If the future of one universe seeds the beginning of another, does memory itself leave a trace across eons? Even darker possibilities were raised? Quantum field theory allows for the concept of the false vacuum, a metastable state of energy. If our universe resides in such a state, then one day, perhaps tomorrow, perhaps in billions of years, it may decay into a lower energy form. Could decay would sweep across space at the speed of light, erasing all structure, rewriting physics itself. The Big Bang, in this terrifying view, may not have been the first transition, but simply the most recent dot. At the heart of all these theories lies a paradox. The human mind seeks beginnings, but nature may not provide one. Perhaps the universe has no origin, only cycles. Perhaps it has no cycle, only infinite inflation. Perhaps it has no outside, only transformations within. Each theory carries weight, each supported by fragments of mathematics, but none yet confirmed. And here, speculation becomes reflection. If Penrose is right, then the heat death of the cosmos is not the end, but the beginning of another. If loop quantum cosmology is true, then the universe may have bounced an infinite number of times, each cycle erasing and renewing the arrow of time. If string theory's brains collide in hidden dimensions, then reality may be wider than any telescope could ever reveal. If eternal inflation rules, then our cosmos is one bubble in a sea of infinity. And in that infinity, every possibility exists. Somewhere, for cosmologists, these are not idle fictions, but serious attempts to break the wall of singularity. Yet, none has yet pierced it fully. Observations continue, but the deeper science looks, the more the question remains suspended in mystery. What breath before time began? Was the Big Bang a true creation, or merely a transition? Is time an arrow, or a circle? Is the universe unique or infinite? Each theory suggests an answer, but none closes the door. Instead, the door opens wider, onto a cosmos that is more strange, more boundless, more unsettling than even the shock of the singularity first implied. In seeking beginnings, science may have uncovered something more profound, that beginnings themselves are illusions. Human attempts to draw boundaries in a reality that may have none. Theories and speculations swirl, like galaxies in an expanding night. Each is a story written in mathematics and wonder. Each is an attempt to hear the breath of the universe and the silence before time. Scientific tools and ongoing testing. The questions left behind by the Big Bang are not only philosophical, they are also scientific, testable, and measurable. If the right instruments can be built, and if patience is stretched across decades, to search for what breath before time began, humanity has constructed some of the most powerful machines ever imagined, each designed to listen for echoes, to trace shadows, to uncover signals older than galaxies. The first canvas remains the sky itself. The cosmic microwave background, the faint afterglow of creation, has been mapped in exquisite detail by satellites. COBE, launched in 1989, was the first to confirm the tiny ripples of temperature that seeded galaxies. WMP followed, sharpening the picture, revealing a universe remarkably uniform, yet flecked with subtle irregularities. Then came the Planck satellite, whose high-precision maps transformed cosmology into a forensic science of origins. Each pixel, each tiny variation in temperature, carried within it the possibility of an answer, the fingerprint of inflation, the scars of a previous universe, or even the faint trace of collisions with other worlds. Beyond our horizon, the microwave background is not the only messenger. Gravitational waves, ripples in space-time itself, promise an even deeper probe. Detected for the first time in 2015 by the Laser Interferometer Gravitational Wave Observatory, or LIGO, these waves have already revealed black holes, emerging billions of light years away. Yet some physicists dream of detecting even older waves, primordial ones, stirred in the first instant of inflation. Such signals, if found, would carry the signature of what came before light itself. They would be echoes of the universe's earliest breath. Future instruments, LISA in space, pulsar timing arrays across the galaxy, aim to listen for these ancient tremors. Telescopes, too, are probing further back in time. The James Webb Space Telescope, launched in 2021, now stares into the infancy of galaxies, revealing structures far earlier than expected. Each discovery sharpens the question: did these galaxies form as inflation predicted, or do they hint at an origin stranger still? Other missions, like Euclid and the Nancy Grace Remote Space Telescope, will map the distribution of galaxies with unprecedented clarity, searching for the fingerprints of dark energy and testing whether cosmic acceleration itself is constant, or shifting, perhaps a clue to cycles of expansion and collapse on Earth. Particle accelerators like the Large Hadron Collider seek to recreate conditions near the first moments of the Big Bang by smashing particles at energies approaching those of the early universe. Physicists test the fabric of matter itself, the Higgs field, supersymmetry, hidden dimensions. Each collision is a miniature echo of creation, a flash that may reveal the deeper laws that govern the universe before time had meaning. Other experiments turn to the vacuum itself, the so-called nothing from which quantum fluctuations arise. Devices probe for dark matter, the invisible mass that outweighs stars, and for variations in fundamental constants that might hint at the influence of other universes. In the quiet of underground laboratories and the silence of interstellar space, detectors are built not to see what is, but to sense what should not be. Each tool is both an act of measurement and of faith. The cosmos does not give up its secrets easily. Signals are faint, scattered across vast distances and eons. To glimpse the universe before time is to search for whispers in a storm. Yet science persists, layer by layer, building instruments, not only for the present, but for generations to come. And still, the most profound testing may not be physical at all, but mathematical. The effort to unify relativity with quantum mechanics, to write a single equation that explains both black holes and the birth of the universe, continues to drive theoretical physics, string theory, loop quantum gravity, holographic models. Each is a mathematical telescope, an attempt to peer into the singularity itself. Each equation is not only an act of science, but an act of imagination. These tools, telescopes, satellites, detectors, colliders, equations, are humanity's way of pressing against the wall of the beginning. They are designed not merely to observe, but to challenge the assumption that the beginning was absolute. If cycles exist, their imprints may remain in the oldest light. If bounces occurred, gravitational waves may carry their memory. If other universes touched ours, their collisions may be written faintly in the sky. The work is unfinished and may never be complete. But each measurement is a step toward an impossible horizon, a horizon where science seeks not only to describe the universe, but to ask what came before the word universe had meaning dot in the hum of detectors, in the silence of telescopes drifting through space, in the chalk marks of equations scrawled across blackboards. The search continues. Humanity has built machines that can hear the echoes of creation. The question is whether they can hear beyond it. Philosophical reflection / emotional close, and the question of beginnings dissolves into something more profound. Science has traced the universe back to its earliest measurable moment, has mapped the afterglow of its birth, has built theories of inflation, of cycles, of infinite expansions. Yet beyond all equations and data, the mystery remains. Did the universe breathe before time began? Or is the very idea of before an illusion, a word that loses meaning when applied to the horizon of time? To breathe is to live, to oscillate. Between presence and absence, between motion and stillness, perhaps the cosmos itself follows this rhythm. Each expansion and contraction, each cycle of eons, may be nothing more than the universe inhaling and exhaling across eternity. In this vision, the Big Bang was not creation, but only a breath. One moment in an eternal cadence too vast for human minds to contain. And yet, there is another possibility, more unsettling still, that there was no breath before, no cycle, no memory. That time itself was born with the universe, and that asking what came before is like asking what lies north of the North Pole. If so, then the universe is finite not only in age, but in comprehension. It has boundaries not of space, but of meaning. For humanity, both visions are staggering. An eternal cosmos humbles us with its scale. We are but a flicker in one breath among infinite breaths. Our lives less than sparks against the rhythm. Creation, but a finite cosmos carries a different weight. If this was truly the first beginning, then we are participants in the only story the universe has ever told. We live within its one unfolding, its one arrow of time. Both possibilities are profound. Both reframe what it means to exist. Philosophers have long wrestled with the tension between eternity and creation. Ancient myths spoke of cycles, of universes destroyed and reborn, of ages unfolding like waves upon a cosmic ocean. Religions envisioned creation ex nihilo, a moment where being emerged from nothing. Modern science, in its own way, now stands between these two visions. Its instruments reveal a beginning, but its mathematics hint at cycles. Its theories speak of boundaries, yet whisper of infinities beyond them. Perhaps the truth is that reality resists human categories. The mind seeks clarity, beginnings and endings, causes and effects. But the cosmos may be stranger than such a language. Allows. Time may not flow as a line, but as a loop. Space may not end in emptiness, but in transformation. What we call nothing may not be absence, but a hidden fullness. A field from which universes emerge, and so the search itself becomes the meaning. The act of building telescopes to glimpse the first light, of writing equations to pierce the singularity, of imagining cycles and multiverses. This is humanity breathing with the cosmos. Our questions are extensions of its rhythms, our wonder, a reflection of its mystery, Perhaps this is the true significance of the Big Bang, not simply that it happened. Not only that it began the universe we know, but that it drew humanity into the deepest confrontation with existence. It forced us to face the boundary of time, and in doing so, to ask what it means to be alive within it. The universe may breathe eternally, or it may have breathed only once. We may be one spark in a chain of infinite cycles, or the sole witnesses of the only creation we cannot yet know. But in the act of asking, in the patience of building instruments that listen to the silence, in the courage of imagining what cannot yet be seen, we share in something vast. The stars burn and fade. Galaxies drift apart, entropy rises. But the mystery remains. And perhaps in the end, the mystery itself is the message that existence is not given to us as an answer, but as a question to be lived, to be wondered, to be felt. The universe began with a breath, whether it was the first or one of infinite. Breaths we do not yet know. But as we look upward into the night, listening to the faint echoes of creation, we too breathe. And in that rhythm, fleeting and fragile, we share in the pulse of the cosmos.